Okay, we're in Rogawski's calculus book, section 6.2, page 348, doing problem 14. The instructions here say find the volume of the solid with the given base and cross sections. Okay, and the base is the region enclosed by y equals x squared and y equals 3. The cross sections perpendicular to the y-axis are rectangles of height y cubed. So let's see what we can do with that. Okay, so what does the base of the region look like? Well, y equals x squared. Of course, looks like that going through 0, 0. And then y equals 3, right, is that constant line. So this is what the base region looks like. And then the cross sections, it says, are perpendicular to the y-axis. That's really important. So you've got to draw a line perpendicular to the y-axis. That's what a cross section looks like. And it says it's a rectangle. So if you could just imagine a rectangle sort of poking out there, that rectangular shape poking out there. Now I'm going to draw a picture of that cross section. You've got this piece, then you've got this piece. Now notice at a height y, how wide is the base of the rectangle? The base of the rectangle is, well, it's whatever this x value is, okay, there, and whatever the x value is here. Now what is the x value in terms of y? Notice that x equals, say, the square root of y, if y equals x squared. That's the distance from here to there. So this whole distance is actually 2 square root of y. Square root of y, square root of y. That's how wide it is. How tall is it? Well, it tells us in the problem the height of the rectangle is y cubed. So part of what we have to do is say, okay, that particular cross section, what's the area of that cross section? The area of that cross section is base times height, 2 times the square root of y times y cubed, or you could write 2 times y to the 3.5 if you wanted. Now, as far as finding the volume, we're going to have to slice perpendicular to the y-axis. That means we're slicing along the y-axis, dy. We start slicing at 0. We finish slicing at 3. And then I'm going to put in what those slices are, actually. So 2y to the 3.5. Sound good? Okay, so this is actually a pretty nice thing to integrate. This is a constant scalar, so we'll pull that out. The integral of y to the 3.5 is y to the 4.5 times 1 over 4.5. We're evaluating from 0 to 3. Okay. Now, evaluating this thing at 3 works pretty simply. That's 2 over 4.5 times 3 to the 4.5 minus plugging in 0, which is 0, right? Now, you might simplify this a little bit. 2 divided by 4.5. Well, you could think about 4.5 as 9 halves, right? So if that's 9 halves times 2, you could just say, well, this is just 9. Oops. This is just, sorry. Let's see, 9 halves in the denominator is 2 over 9, so we've got 4 over 9 times, let's see, what's that? That's 3. Let's write this as 3 squared times 3 squared times the square root of 3, right? There's 3 to the 4.5 altogether. Why do I write it like that? Because 9 and 3 squared cancel, so I get 9 squared, that is, sorry, 3 squared, which is 9, times 4, that's 36 root 3. That's the volume.